And we are ready to go.
Okay, so hello everyone, and welcome to our second and final Ask an Astronomer event of the summer. My name is Stephanie, and I work with the BC Summer Reading Club. And as you probably know, our theme this year is space, and we are delighted to be teaming up with our friends at the MacMillan Space Centre to explore our universe. And if you stick around to the end, I'll be announcing an amazing prize opportunity for a one-on-one Ask an Astronomer session. We greatly acknowledge our funders at the Ministry of Education, Libraries Branch, and QPBC and their generous support for libraries and children's literacy. The BC Summer Reading Club is sponsored by the BC Library Association, and we are privileged to have our office and be presenting this webinar in the city of Vancouver, which is located on the unceded territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, Stolo, and Tsleil-Waututh nations. And so now let me turn things over to Trish and Rachel, our lovely friends from the Space Center. There you guys go.
Yay! Stephanie, thanks for the great introduction. Awesome. Hey, Rachel, how are you doing today?
Doing pretty well. The sun is out. The Perseid Meteor showers are peaking today, so very exciting.
Absolutely. We're going to talk about that a little bit later, but we are hoping for clear skies for everybody across the province. So we are not only live now, but we are live to YouTube, Rachel. And we put a message in there that if people have some questions as we present our talk today, they can add them to the chat feature. And we really want kids and people across the province to let us know where they're watching from. So where are some of those library communities that you're viewing from? Are you down in the Kootenays? A shout out to the Trail Library, or are you viewing from up north as well? So let us know, are you having clear skies right now? And are you going to check out the Perseid Meteor shower tonight? So Rachel, we've got a lot to get through in the next 30 minutes. So I'll let you take it away.
We do. So we're going to talk a little bit about what it's like to live in space. So I'm going to share my screen here, and hopefully you'll be able to see an astronaut in a car that says, "This could be you flying off into space." Trish, do you see that?
Yes, I do, Rachel.
Awesome. All right. So like every other thing that we know of, your dog, your cat, your brother, and your sister, humans live on Earth and we feel Earth's gravity. You can feel it right now as the Earth's gravity is pulling your butt down onto your chair or your couch. So it's not surprising that our bodies behave a little bit weirdly when we put them into space where there's a little bit less gravity. Now, way back in 1961, the Russians were really worried about putting someone in space for too long. They weren't really sure what would happen. So when they sent Yuri Gagarin into space, they only sent him up there for about an hour and a half. Now, dealing with constantly floating around in space affects everything, from eating to sleeping, from working to going to the bathroom. Weightlessness makes doing all of these things a little bit more complicated. Now, astronauts on the ISS experience something called microgravity, and we can see the effects of microgravity when astronauts and objects float in space. Here, micro means really, really small. So here, microgravity would mean where gravity is really small. Now, you can find a small amount of gravity everywhere in space. Gravity holds your feet to the ground, but it also holds the moon in orbit around the Earth or in orbit around the sun, and the sun in place in the Milky Way galaxy. Now, the ISS orbits Earth a few hundred kilometers up in the air, so really high up. Now, at this height, Earth's gravity is a little bit less than what it is on the surface. And that means that if you climbed a ladder all the way up to the space station, you would weigh a little bit less at the top of the ladder. But the ISS is also moving, it's falling around our Earth in orbit, so they have even less gravity on the space station. And so they feel weightless and they float around. But space affects just about everything in the body. So let's talk about some of the differences between how the body works on Earth and how it works in space. Now, as you can imagine, our sense of balance is terrible in space. Astronauts often feel very confused, not knowing which way is up, which way is down. They even have problems feeling where their own arms and legs are. So here I'm showing you on the left, people in an airplane nicknamed the Vomit Comet. It flies up and down, almost like it's going over big hills, and it makes you feel like you're weightless for a little bit. And the feeling that I get is a lot like when you go on a roller coaster and you feel your stomach kind of drop. Now, NASA astronauts use this plane to train for space so they can get used to the feeling and hopefully not vomit on the ISS. Now, another problem is exercise. Now, most of your body weight comes from water in some form or another, and on Earth, this liquid is affected by gravity and it settles more downwards towards your leg in your body. Now, in space, these fluids get to move around from your legs to your head. And so the extra fluid in your head leads to what astronauts like to call the space sniffles, which is essentially your sinuses get blocked. So by exercising in space, astronauts can fix these space sniffles a little bit by getting the blood pumping. So now that we know the effects of living in space long term, let's talk about what a day in the life of an astronaut is like. Now, I put day in quotation marks because the concept of a day on board an orbiting spacecraft is a little bit weird. Every 24 hours, astronauts on board the ISS will experience 16 sunrises and sunsets as they orbit our Earth every 90 minutes. So here's an example of what a typical day on the ISS might look like. The crew are awoken by an alarm each morning. They climb out of their sleeping bags that are attached to the wall to prevent them from floating away while they sleep. They get dressed, they wear disposable clothes, they get replaced every 3 days because there aren't any washing machines or dryers on the ISS. Then comes the first of 3 meals in the day. Drinks and soup are served in plastic bags and sipped with straws. Magnets and Velcro keep utensils from floating away from the dining table. Now, if you stay too long in this kind of space environment, it actually dulls your sense of taste. So spicy food is a popular choice among astronauts. Now, after eating, astronauts settle down to do their assigned tasks for the day, either supervising experiments or doing maintenance on equipment. Now, a less stressful day involves doing a little bit of exercise. A few hours of daily exercise helps keep the muscles healthy and helps a lot with the space sniffles. Now, recently, we sent humans Bob and Doug into space, and they actually got back to Earth just last week. They launched on May 30th from US soil. And that's really a historical moment because the space shuttle program, which ended in around 2011, NASA actually didn't have any spacecraft that were capable of sending people into space. So we ended up borrowing rockets from the Russians. We borrowed the Soyuz rockets, but that was really, really expensive. It actually cost around $80 million US to send one astronaut into space. And so now with the SpaceX, NASA can use these private companies to fly astronauts into space, and hopefully it'll cost a little bit less. Now, astronauts Bob Behnken and Doug Hurley became the first humans to launch aboard a SpaceX Falcon 9 rocket to the ISS, and that hopefully marks the beginning of regular crewed flights to the space station. And it took them a really long time, actually, to get to the ISS, almost a full day. It took them 19 hours for them to finally set foot on the ISS. Now, I think the Falcon 9 rocket is really cool. It was launched from the Kennedy Space Center in Cape Canaveral in Florida. And the reason why I think it's really cool is because it's a reusable rocket. Rockets are very expensive, so being able to reuse some parts of it saves us a ton of money. All right, and that brings us to the end. So Trish, I'll throw it back to you if I could figure out how to stop sharing my screen here. There we go.
Sounds good, Rachel. Thanks. Hey, I thought before we get to the question and answer, I would like to show everybody, if I can spotlight my video for a sec, some astronaut food, since I have that here. And it's by far one of the most common questions we get at the Space Center is, what can you eat in space? What would I have to eat if I were an astronaut and I went to space? So I thought I would bring a few examples today. So this is probably one of my favorite ones, and I'm going to hold it up nice and close and let you see if you can guess what that might be. Have you ever seen a spaghetti dinner fit in a package like that? So the food that astronauts get to take with them to space is just normal food that we have here on Earth, but it's packaged very differently. Remember how expensive Rachel said the rocket is to get astronauts to space? Well, the food certainly can't take up extra space or weigh a lot. So it's dehydrated because they don't have a fridge or a freezer or a way to store it in space, and it needs to be there for a long time. So you can see in this package here, it's kind of like camping food. Everything has the water taken out of it, and it even has the instructions on it. So I'm going to hold it up nice and close, see if you can see it here with the camera. Spaghetti with meat sauce, add 100 milliliters of hot water, and then wait 10 to 15 minutes. Well, doesn't sound like much cooking if you ask me, but that's how they prepare their meals in space. And if you look at the end here, it's got a really handy little spout. So it just sticks underneath the water faucet. A little needle comes out and inserts the water here, and then they can wait. Now, the one thing I like looking at this, and I'll hold it up close again, can you see the instructions are actually in a different language? So what Rachel talked about, Bob and Doug being American astronauts, well, there's also Russian astronauts that live aboard the ISS at any one time. Now, I'll show one other piece of space food that I have at home, because I think everybody can relate to having oatmeal and brown sugar. So there's the instructions there. You're going to add hot water and just wait 2 to 5 minutes, and then check that out. Nothing like eating oatmeal in space. And then they would open it up as well and just scoop it out with a normal spoon. Now, Rachel, I had a couple of quick questions, if I can, before we get to question and answer, because I really wanted to show this great picture I have. Let's see if I can figure out how to share my screen here. I'm going to hit this button here and see if we go to this one. And perfect. So I'm going to hit this right here. Now, how many people at home have ever made Mexican food? Tacos or quesadillas? Well, in space, you get to make it without a table. So here's a tortilla where the astronauts have squeezed on the beans, and you can see the onions aren't floating away. They're stuck to it. Put a little cheese on top, and then maybe a little bit of spice as well. And a dinner table in space kind of looks different than here on Earth, because the apple and the tomato that you can see in this picture, well, they're just going to float there until you need them. And you can see down at the bottom a can of tuna that's opened, or some crackers. Everything needs to be Velcroed down so it doesn't go flying around the spaceship. So a dinner table in space is a little bit different than certainly what we have here on Earth. But in fact, it's a lot cooler, because your food, see if I can stop sharing here, your food will be stuck to the, all right. Rachel, I'm going to send it back to you here. I'm going to cancel my spotlight. There you are there. Now, getting to the question and answer, I had one really cool question that I wanted to open with today, and it came from Abby. And she asked the question, do stars really sing? Now, I typed that into Google, Rachel, and the first thing that came back was Justin Bieber singing a song. So I don't recommend Googling stars singing, but maybe the sun singing or other astronomical stars. That's what we're talking about, right?
Yeah, exactly. So I actually have a short little video clip, an audio clip, to show you what star singing sounds like. So I'm going to share my computer sound. That's important. And Trish, do you see Singing Stars video popped up on your screen?
I do. It's going to start in a second here. There it is.
Alrighty, so I'll play this little short clip, and then I'll explain what happened. Crazy that
I gotta say that kind of sounded like my radio was not on the right channel. So tell me what we were listening to.
A little bit. So it does sound like static. And the reason why it sounds like static is because what they're really doing is they're taking light and they're transforming it into this kind of sound. And they're taking really variations in light. So really tiny fluctuations and differences in the light. And they're translating it into sound or into music. So it sounds a little bit like random noise, sounds a little bit like static, but it's really a different way of looking at a star. And astronomers actually have a whole field dedicated to this, and it's called asteroseismology. And so that's when you look at tiny little differences in a star, and you, by looking at this and by looking at the sound or looking at the variations in light, they're able to figure out some details about what's inside of the star without even having to go there.
Very cool. I like that, Rachel. Another way of using science to figure out what stars are made of.
Exactly.
All right. So our first question I have here is coming from Eloise, and she wants to know, is there any bacteria in space?
Oh, that's a good question. So I know that in the news, I think last year, there was news about tardigrades in space. And tardigrades are these really tiny water bears. And they found tardigrades on the International Space Station. And so they're not quite bacteria, but they are some sort of organism floating around in space. So we do have other living things in space besides humans. And we even have things like plants, flowers. I think fruit flies are on the space station as well. So lots of different things.
Very cool. And that kind of leads us into Hunter's question, was asking, is there any garbage in space?
This is my favorite question because it's great timing because a meteor shower is happening right now. And I like to joke that when you do see a streak of light going across the sky, there is a chance that it's a meteor, but there's also a chance that it's the ISS getting rid of their space waste or their space poop, and they're burning it up in the atmosphere. So whether it's a rock or a meteor going through space, or if it's space poop, we'll never know.
That's really a good question, because someone asked that in the chat, if I can find that as well. Do astronauts drink their urine? And the answer to that is yeah. They really do recycle everything on the ISS. So when you were showing us pictures of living in space and working out on the treadmill and sweat comes off an astronaut, they'll recycle that as well into drinkable fluid.
Mm-hmm.
All right, so let's get to our next question here. You already talked about gravity being in space. So Jesse wants to know, how big can a star get, Rachel?
Ooh, so that's a good question. So that's an interesting question because it actually plays into how stars evolve over their lifetime, or what their life cycle is like. And how much stuff you have in your star, how much matter, and how big it is actually tells you what the star is going to end up like at the end of its lifetime. So for us, for our sun is not that big. It's actually kind of small on the scale of stars, and it has a lifetime of around 10 billion years. And we know that it'll become a small little white dwarf. But if you have stars that are much, much bigger than our sun, let's say they're like 100 times bigger than our sun, then we know that they're going to end up as a black hole. So how big stars can be really depends on how much stuff you have in one space, and whether or not that gravity can start clumping things together and forming this ball of gas.
Really cool, Rachel. And that kind of leads to a question that we got online in the chat from Stephanie, that wants to know about figuring out about the stars that are shining above her library on Pears Island. So is there an easy way online that she can check out and figure out what's going on in the nighttime sky? And that kind of leads into talking about what's really going on tonight and over the next couple of days in the night sky.
Yeah, so the best way to do that is to use a star finder, or what we call a planisphere. And the Canadian website, I believe, has a specific star finder rated for our latitude, because it does vary depending on where you are on the globe. So you want to make sure that you have the right one for your region. And what you can do is you can take the star finder, you kind of twist it around so it's showing the date that you are observing at, and then you're going to hold it above your head, and it'll show you what you can see in the nighttime sky, and it'll show you all the constellations and the names of the constellations on the nighttime sky. But what you can also do is, if you don't have a star finder handy, is you can use maybe a mobile app, or I like to use a website called timeanddate.com, because I can input where I live and it'll show me what the nighttime sky looks like and highlight constellations, highlight planets, and I can pick what time of year I'm going to look at and what time of day. So I think that's very, very useful. And so speaking of what's going on in the nighttime sky now, We talked a little bit about the Perseid meteor showers that are happening. They are an annual meteor shower, and I think they're one of the most spectacular for us in the Northern Hemisphere because they're very prolific. There's a lot of meteors streaking across our nighttime sky. And today's a perfect day to talk about it because the peak of the meteor shower is happening right now. So that's when we'll see the most amount of meteors you'll ever get, even though the Perseid meteor shower ranges from mid-July to around the end of August. And so what you want to do is you want to look at the constellation Perseus. And you can do that by using something like a star finder, a mobile app, or you can look for a constellation called Cassiopeia. It'll look like a big W, and you can use the Big Dipper and the Little Dipper to help you find it. So once you found this big W, the Perseus constellation will be right underneath it. And you'll want to look there to see if you can find and see shooting stars streaking across our nighttime sky. Trish, have you seen any meteors yet?
I've been looking for them, Rachel. I've seen lots of satellites going over, but nothing streaking across the sky. And that kind of leads us into Mustafa's question, which was asking about, can any of those streaks of light or what we're seeing in the shooting stars come down and actually land on the Earth? So would that hit the Earth, and would that be a problem?
So we have different classes of rock, basically, and it kind of depends mostly on its size. So we have something called meteoroids, and that's kind of small particles, small specks of dust that go around our sun and orbit our sun. And then the next kind of thing we have is a meteor. And so that's a little bit bigger. And if a meteor happens to go through our atmosphere and it burns up, if it's big enough, then it might be able to survive that burning in the atmosphere and actually end up landing on our Earth. And that's when we would call it a meteorite. And there's two classes of meteorites. There's falls and there's finds. Falls are the ones that you see coming down and you go and track them, and then you go and pick them up. So you watch them fall from the atmosphere to the surface of the Earth. And then we also have finds, where you've just stumbled upon a meteorite in your backyard, perhaps.
That's cool, Rachel, because usually we're telling all of our friends with the Summer Reading Club to look up at the nighttime sky. But we also want them to look down in case they find a meteorite that's fallen on the ground.
It could be.
Very cool. So if we're going out tonight and we want to see the Perseids, can you give us some information on where we should go, what we should do, and what time would be the best, especially for our younger viewers, because They might have to wake up later.
Yeah. So you want to go to the darkest location possible. So you want to get away from city lights, get away from your house lights. Something like a dark field would be good. And you don't need any special equipment. You just need an eyeball or two. You don't need binoculars, don't need telescopes, but you want to let your eyes adjust to the darkness. And you want to give yourself around 30 minutes for your eyes to adjust. So that means no using your cell phones or anything that gives off light during that time. And so, again, you want to look for the constellation Perseus. I would highly recommend perhaps using a mobile app that can show you. You point at the sky, it'll tell you where in the sky the constellation is. And yeah, so you really want to get around 11 p.m., that kind of time, or you can also go early in the morning in those pre-dawn hours. And it's actually better to go in the morning because we are heading into or towards the debris or the stuff that causes the meteor showers rather than away. So it's better to go early in the morning, but if you can't stay up that late, you can always try staying up just to 11 p.m. and seeing if you can see those streaks of light.
Very cool, Rachel. I think we'll end with a couple more questions that seem to be really popular both in our chat and online. And one is talking about black holes and the difference between black holes, white holes, and wormholes. And then certainly talking about aliens or what exactly we're looking for in the solar system. So I'll let you choose which one you want to tackle first.
Okay, I'll start with the black holes because that's my favorite question that I get at the Space Center. So a white hole is essentially the exact opposite thing that a black hole is. So a black hole, we know that as soon as you cross the horizon, as soon as you cross the boundary, you are forced to go towards the center forever and ever. But a white hole ejects or spews out everything that's inside of it. So it actually doesn't let anything stay inside the boundary or inside the horizon of a white hole. So they're really exactly opposite scenarios or exactly opposite objects. Now, the cool thing about an idea of a wormhole is if you had a black hole that was spinning around or rotating around fast enough, then maybe we could actually go through the black hole and end up somewhere else. So what a black hole or a wormhole really does is it connects two different points in space-time that are really, really far away. It would take us forever to travel between those 2 points, but it just brings them really close together. So hopefully we can travel to other star systems where there might be aliens or life out there.
That's really cool, Rachel. I know people, especially my niece, who recently went on a long car ride with me, would love a wormhole to eliminate that 7-hour drive to Grandma's house. So let's keep working on that wormhole. And just before we switch over to talk about aliens or the search for alien life, Nathan had a really good question. Will a black hole ever run out of room? Will it ever fill up? Can you feed a black hole too much?
Oh, that's a great question. And the answer is not really. And part of the reason for that is when you look at a black hole, for example, the black hole picture that we got recently, you would see a lot of orange stuff, that orange light surrounding the black hole. And what that really is kind of the crumbs left over from when a black hole is having its late night snack on a star, perhaps. And so black holes are truly messy eaters, meaning that not a lot of stuff actually makes it into the black hole, and it actually makes it all around the black hole, just like when I eat dinner. It gets everywhere, and you can see traces of it on my face, and like you can see around a black hole. So, and especially because a black hole is really this infinite pit, you can think of it like that, an infinite pit, an infinite, almost like a bag of holding where you can throw an infinite amount of stuff into it and it'll never be full. So a black hole works very much the same way.
That's really cool. Good answer, Rachel. And then ending about our search for extraterrestrial life. And that kind of goes back to bacteria or what we're looking for as we explore planets. I know there's some really cool stuff going on Mars right now.
Mm-hmm. So the search for extraterrestrial life, or what we call SETI, is super interesting. And the reason I think it's interesting is because we are looking for other signs of life elsewhere in the universe. And so far, we are only aware of our form of life here on Earth. So it would be incredibly interesting to find life elsewhere. And so how we're doing that is we're looking for life that looks a lot like us. And by looks a lot like us, I don't mean that it has a head, 2 arms, and 2 legs. I mean that it gives off like things like carbon dioxide that we breathe out. It needs oxygen to live. It needs water to live. So it looks and feels a lot like us, but hopefully we can find that elsewhere on different planets, or what we call exoplanets, living outside of our solar system. But we are also looking inside of our solar system to see if we can find signs of life. We're looking at places like Mars, which might have had traces of ancient life there. We don't know. We're sending rovers there now. Perseverance is on its way to find, hopefully, some samples of ancient life. But there's also places like Titan, which is Saturn's largest moon. And Titan's really interesting because it does have liquids on its surface. And so that's very exciting because we're looking for something that looks like Earth. We have liquid water on our surface. But with Titan, it has these lakes and rivers of something else, not water, but actually methane. And so if there was a life form that was based on methane, then maybe it could live on Titan. So it's really all up in the air
cool.
Where we're going to find aliens. But I really do believe, given how old our universe is and how big our universe is, that we probably will find life. And I think it's just a matter of time.
That's really cool, Rachel. Last question before we invite Stephanie to come back and join us, and it's really a popular one too. What inspired you to go into the field of astronomy, Rachel? So what inspired you to go into further looking at the stars?
So I really like looking at the extremes of things. And that's me speaking partly from my physics background, but also from an astronomy background, because when we look at things in space, none of these things could exist on Earth. First of all, we don't have enough room here on our planet. And second of all, we don't have the technology to make these extreme objects that we find out in space, things like black holes, neutron stars, pulsars, magnetars, all these things exist out there in space that we would never see here on Earth. So I think it's really interesting to be able to look up into our night sky that we've been doing for millennia. Humans have been doing that forever, and look at these objects and see what kind of physics, what kind of phenomena we can see in these really extreme objects. And I love that idea.
That's awesome. All right. Hey, Stephanie's back. Let's ask. Hey, Stephanie, thanks for joining us. Rachel and I have had a great time connecting with you and everyone at the Summer Reading Club, and we hope that everybody out there is taking time, if not tonight, in the next couple of days, to look up at the nighttime sky and see some really cool things. So I know you wanted to wrap up with a few things today.
Thank you so much, Rachel and Trish. You're both always so wonderful and so informative. I feel like I've learned a little bit about the meteor shower tonight, so I'm going to stay up a little bit later to watch, but also report back to my colleagues and let them know the scoop, because I feel like I'm more knowledgeable now. And so I'm going to share our screen to show everybody where you can find information about our exciting prize. So we are very, very, very excited to announce that our friends at the Space Center, at the H.R. MacMillan Space Center, have generously donated a private one-on-one Ask an Astronomer session for a lucky reader who completes their Summer Reading Club goals this summer. So we're just going to randomly draw someone from that list, and then you're going to have a session with Rachel. Trish might be there, who knows? But basically, Rachel will answer all of your questions. Rachel can also take you all over the world and like over.
It's true. I can fly you around space. We can fly to the Milky Way, anywhere you want to go.
Yeah, so amazing things. So the way that you can find out for more information, I'm going to show you my little screen. And so, does everyone see my screen?
Yeah.
Yes. Yeah.
So basically, you just want to go to our main website, bcsrc.ca, and you can either click fun things for younger kids or fun things for older kids. And so we'll click the older kids one, and then on our side option right here, we have a little tab for prizes. So click that, and our astronomer prize should be the first thing on the top right here. So we've got some other prizes going on this summer, but this is the one that we're very, very excited to announce. And we're so thankful to our friends at the H.R. MacMillan Space Centre for making that possible. And I think that is it for us. Thank you, everybody, for joining us this summer. And thank you for all your amazing questions. There were so many black hole ones. So glad that we answered some of those questions. And yeah, so thank you. Happy reading. And we'll see you on the website. Okay.
Thanks, everyone.
Wonderful. Thanks, everyone. Happy reading. And we're out.